Morning, guys. Happy Friday. This is our 7.2 solving systems using elimination. I think elimination is the method that we're most comfortable with, so hopefully you guys will find this to be a little easier than substitution. But again, this is a review of stuff that you've done in early high school. When you're solving with the method of elimination, you want to make sure that your x's, y's, and your constants are all lined up. Meaning your x's are on top of x's, y's are on top of y's, there's an equal sign, and then your constants are on the right side of the equal sign. After you do that, you then want to make, somehow, either by multiplying by a fraction, multiplying by a whole number, multiplying by a negative, but you want one of the coefficients of one of the variables to be exact opposites. It doesn't matter which one you choose. Sometimes they lend themselves to go one way or the other. You know, you can see what's the easiest one to do. Sometimes you can't. You just have to figure it out. So let's go through solving this. If you look at this first one, I'm going to look and see, okay, my x's are on top of each other. My y's are on top of each other. I have an equal sign, and then my constants. So we're good to go. You could eliminate x's or y's, whichever you want. I'm going to eliminate y's because they're already set up to eliminate. I notice I have a positive 2 up here, and I have a negative 2 here. I know those are exact opposites. So when I combine, when I just add down, this is another way you can look at it, I have 3x plus 5x is 8x. Negative 2y and positive 2y cancel out. I have equals 4 plus 8 is 12. Divide both sides by 8. And my answer is x equals 3 over 2. Now some of you are saying, can I just make that 1.5? Yes, you can. But depending on what the directions say, depending upon how your problem is set up, if it starts off with fractions, your answer should be in fractions and vice versa. So just be careful with what they're asking you to do. Now, once we find out what x equals, we now plug back in to see what y equals. Now, when you go back to plug in, it doesn't matter which one you plug into. I'm going to just plug in the top one for whatever reason. That's just what I feel like doing. So I'm going to say 3 times, instead of x, I'm going to put 3 over 2. Plus 2y equals 4. This is called back substitution. We're plugging back in to find out what the other variable equals. So this is 3 over 1 times 3 over 2. It gives me 9 over 2 plus 2y equals 4. So I'm going to subtract 9 over 2 from both sides. Subtract 9 over 2. So yes, we have a fraction, but no big deal. 2y equals, if I change 4 over 1 to something over 2, that's going to give me 8 over 2. So 8 over 2 minus 9 over 2 gives me negative 1/2. Now I divide both sides by 2, divide by 2, so y equals, I'm going to keep negative 1/2, change, and 2 over 1 is going to flip to 1 over 2, so this is negative 1/4. Now I have two values. I have an x value and a y value. When we solve a systems of equations, we always write our answer as an ordered pair. It's the x value and the y value. That is the correct way to write your answer, not just circle x and circle y. So your answer here would be 3/2, comma, negative 1/4. And circle your answer. You can now check, just plug back in for x, plug back in for y in both equations, and verify that they both work. Moving along to this one. Okay, this is a little different because none of the coefficients are just exact opposites of each other. If you notice, the x's are on top of each other, the y's are on top, and the coefficients. Okay, good. So now you make the decision. What do you want to eliminate? I'm going to eliminate the y's simply because one y is positive and one is negative, so that I don't have to worry about changing signs. And I say, okay, 3 and 4, what would be common between them? I can't make 3 into a 4, I can't make 4 into a 3, so I'm just going to multiply the top equation by 4 and the bottom equation by 3. Now, when we multiply the equation, it's through the entire equation on both sides of the equal sign. So this becomes 20x plus 12y equals 4 times 9 is 36. And then on the bottom here, I have 2 times 3 is 6x. Minus 12y equals 14. 3 is 42. So now I see that I can cancel out my y's. So I'm going to just combine. I'm going to add down. 20 plus 6 is 26x. Positive 12 and negative 12 cancel out. And then I have equals 36 and 42 gives me 78. So now we get x by itself. I'm going to divide both sides by 26, and I get x equals 3. So now I take 3, I plug it back in, and I find out what y equals. So I'm going to plug it back into the top. So I have 5 times 3 plus 3y equals 9. Back substitution. So 15 plus 3y equals 9. Subtract 15 from both sides, and then I get 3y equals negative 6. Divide by 3, and y equals negative 2. So remember, to write our correct solution, it's an ordered pair, and it's the x value 3, comma, negative 2. And to make sure that we're correct, we go back, it takes 2 seconds, just go back and just check to see if both of these values, the 3 for x and the negative 2 for y, satisfy both equations. Now, when you will see solutions graphically, if you have 2 lines that intersect at one point, there's exactly one solution. So it would look like, a line this way, and then a line this way, and then where they intersect, that point is the solution. So if you were given a set of equations and a point and said, is this a solution? You would just plug in both the x and y values to see if it makes the equation true. There's another case where you would have equations that are they have infinitely many solutions. That means the 2 lines are coincident or identical. That means it's one line, you graph the equation of the line, and then you graph the other equation of the line, and it's right on top of each other. It's the exact same line, meaning every single point along this line, both of these lines, would satisfy both equations. And then the last situation that we have, when we just have 2 variables in a linear set of equations, linear meaning everything is x to the first power, is no solution. And that's when the lines are parallel. So when they are graphed, they are parallel lines that never touch. So this is when we're talking about linear equations, meaning both x and y are to the first power. So looking at these, it says match the graph with the equations. Well, let's just solve them real quick. Let's look at A. I'm going to eliminate the x values because the x's could easily be, well, I mean, both of them could be, but I'm just going to do x anyways. So I'm going to multiply the top equation by 2. Let me put it down here. So this becomes 4x minus 6y equals 6. And then when we add down, negative 4 and positive 4 cancels out 0. 6 and negative 6 cancels out at 0. And then 6 plus 6 is 12. So we're left with the statement 0 equals 12. Is that ever mathematically true? No. So this algebraically would be a no solution problem. When you have a statement at the end that is not true, 0 will not ever equal 12. So graphically, when I match that, A would go with this graph because these 2 lines are parallel and never touch. All right, so for B, I'm just going to go ahead and eliminate x's again because I can easily just multiply the bottom equation by negative 2 and get that to cancel out. So if I go by negative 2, this becomes, I have 2x minus 3y equals 3, my first equation. And then the second one's going to be negative 2x minus 4y equals negative 10. All right, when we combine, negative 2x and positive 2x cancel. Negative 3 and negative 4y is going to give me, right over here, negative 7y. And then 3 minus 10 is going to give me negative 7. Divide both sides by negative 7. And I get y equals positive 1. Okay, so then I'm going to go do my back substitution. Take y equals 1 and plug it into either equation. I'm just going to plug it in the top one. So 2x minus 3 times 1 equals 3. So 2x minus 3 equals 3. I put that. I'm going to add 3 to both sides. I get 2x equals 6, divide by 2, and I get x equals 3. So I have one solution point, and it happens to be at 3, 1. That means these two lines, when graphed, intersect at one specific point, and that would be right here. So this is letter B. So now I look at the last situation. Again, get rid of whatever you want. I tend to always go with x's, but again, I like to look and see what's going to be the easiest. So I'm just going to multiply the top equation by positive 2, so I can get the x's to cancel out. So I'm left with 4x minus 6y equals positive 6. So when I combine, when I add down, -4, +4 cancel out, -6, +6 cancel out, -6, +6 cancel out. I'm left with 0 equals 0. When you are left with this statement, or a statement that says a number equals the same number, this is called your infinite many. This is the lines are coincident. They lay on top of each other. So your graph looks like this first one, where the two lines are right on top of each other, so it appears as if there's only one line. Okay, so let's do some more solving. We're just going to go through a bunch of different examples here just to get you guys in the habit. Again, solve for whatever variable you want. I'm going to solve for x. I'm just going to multiply the whole top equation by 2. So I have 2x minus 4y equals 6. So when I combine down, -2, +2 cancel. +4, -4 cancel equals 7. Well, is the statement 0 equals 7 ever true? No. So your answer here would be no solution. If you graphed those two lines, they would be parallel. All right, another one. Let's get rid of y's. I keep getting rid of the same thing, so let's get rid of y's on this one. So I'm going to have to multiply the top equation by -2. So I have -2 and -2 gives me -4x, -2 and -y gives me +2y, and -2 times 1 gives me -2. So my x and 4x cancel out, 2 and -2 cancel out, -2, +2 cancel out. When you have 0 equals 0, that means infinite many. That is the exact same line. It's on top of each other. So if you were to graph these two, they would be one line would lay on top of the other line. All right, you guys are going to get some equations on your web assignment and on your test that either involve fractions or variables. And fractions or decimals. A lot of times you guys don't like decimals, you don't like fractions, you don't like that sort of thing, which is totally fine. You can leave it just like it is in decimal form, or you can get whole numbers. The way that we would do that, if you guys notice in this first equation, 3.1, 2.9, 9.5. If I multiplied the entire equation here by 10, would you guys agree with me that the top equation becomes 31x minus 219y equals -95? Now my decimals are gone. We, in a sense, just moved every decimal place over once. So on the bottom, I'm still left with 31x minus 12y equals 41. Now, it's very easy to see which equation would be, or which variable would be easiest to eliminate. So let's just multiply the bottom equation by -1. So this will just change all the signs. -31, +12, and a -41. So when I do this, I'm going to cancel out my x's, obviously, so my 31's cancel out. I have -29 plus 12. Is -17y equals -95 plus a -41, which gives us a -136. Divide both sides by -17, and you get y equals 8. So again, we have to use our back substitution to figure out what x equals. So I'm going to say, okay, 31x minus 12 times 8 equals 41. So we have 31x minus 12 times 8 is 96 equals 41. So I'm going to add 96 to both sides to get my x by itself. So 41 and 96 is 137. Divide both sides by 31, and x equals 137 over 31. It works out to be some yucky decimal, 137 divided by 31. So we'll just leave it as 137 over 31. See if it can cancel. It doesn't, so don't worry about it. So now we need to make sure, go back and check, guys. Put this in your calculator to make sure that 137 over 31 as an x value and 8 as a y value satisfies both equations. And it does, but just make sure, go in your calculator and check that. Now, I understand that's not the prettiest numbers in the world, but that's okay. Like, you will get fractions that don't simplify, stuff like that. But if you notice, 137 over 31, you can give a decimal equivalent, but it's not a terminating decimal, it's a repeating one. So you need to keep it in fraction form. Now, coming over here to this example, if you notice, there's a lot going on here, but there's denominators. Easiest thing to do when you have fractions, guys, is to just multiply through to get the denominators to go away. So I have a denominator of 2, one of 3, and one of 1. So if I multiply this whole top equation by 6, because 2 times 3 is 6, it will eliminate every single denominator. So this first equation, if I divide 6 divided by 2, becomes 3. So I have a 3 on the outside here, and I have 2x plus 5. If I multiply the second equation by 6, well, 6 divided by 3 is 2, so I'm left with 2 times y minus 1. And then I'm going to multiply 6 times negative 4 gives me negative 24. So all we did was just make an equivalent equation, but we got rid of the denominators. We got them to cancel out. I got a common denominator between the two of them, just multiply the whole thing through. So that's, you can do that, or you can work with the fractions if you want to. So now I'm just going to clean this equation up, and then I will have my system of equations to work with. So 3 times 2 is 6x, 3 plus times 5 is 15, plus 2 times y is 2y, 2 times negative 1 is negative 2, and then I have my negative 24 equals negative 24. So 6x plus 2y, and then I'm going to move 15 over and negative 2, so I'm going to subtract 15 and add 2. So I'll have 6x plus 2y equals negative 24, negative 15, and positive 2 is negative 37. And then I have my other equation, 2x minus y equals 21. So now I'm going to solve these two. 6x plus 2y minus 37 is the same thing as this top equation here. We just got rid of the denominator. So now I'm going to eliminate my y's because all I have to do is multiply the bottom equation by 2. So I have my initial 6x plus 2y equals negative 37. And then on the bottom I have 4x minus 2y equals 2 times 21 is 42. So 6x combined down. 6x plus 4x is 10x. Negative 2 and positive 2 cancel. And then I have negative 37 plus 42 equals 5. So we're going to divide both sides by 10, and x equals 1/2. Now your problem started off with a fraction, so it should end in a fraction. If you want to use 0.5 for your back substitution to find out what y equals, but then make sure that your answer is in fraction form. So I'm going to go back to the originals. I'm obviously going to use the bottom equation, 2x minus y equals 21, because that's a little prettier, easier to work with. So 2 over 1 times 1/2, what was it, minus y equals 21. So my 2's here will cancel out. I'm left with 1 minus y equals 21, minus 1 from both sides. Negative y equals 20. Divide both sides by negative 1. And y equals negative 20. And again, make sure you go back in your calculator, plug in your x value and your y value, and make sure it satisfies both equations. So my ordered pair, my answer would be 1/2 negative 20, meaning when these two equations were graphed, they would cross at that one specific point. All right, lastly, guys, you're going to have word problems. You'll have word problems on your quiz for 7.1 to 7.3 quiz. You'll have word problems on your test. You'll have word problems on WebAssign. We're talking about systems of equations. So we're talking about two equations. So a lot of times you want to just try and order yourself. You want to name something an x, name something a y, and keep your information straight. So we're talking about 2 cheeseburgers and 1 small order of fries from a fast food restaurant is a total of 970 calories. 3 cheeseburgers and 2 small fries is a total of 164 calories, 1,640 calories. Find the caloric content of each item. All right, so my first order was 2 cheeseburgers, 1 fry, 970 calories. The second one is 2 cheeseburgers, 2 fries. So the two variables I have here is cheeseburger, did I spell it? Yeah, and French fries. I'm just gonna make my cheeseburgers X and my French fries Y. So the first equation says 2 cheeseburgers, so 2X, and so plus 1 small order of French fries, 1 fry, equals a total of 970 calories. All right, so my second equation, my second order is 3 cheeseburgers, so 3X, and then I have 2 small fries, so plus 2Y, equals a total of 1,640 calories. So there's our system of equations. Now you guys can decide which you want to eliminate, x's or y's. I'm going to eliminate y's because I can just multiply the top equation by -2. So that leaves me with -4x, -2y equals -1940. And then we solve. 3 minus 4 is going to give me -x. My y's cancel, and I have equals 1640 minus 1940 gives me -300. So divide both sides by -1, and x equals 300. So now we figure out that each cheeseburger has 300 calories in it. So let's plug back in. Let's use our back substitution to find out how many calories are in the French fries. So I'm going to use the 2x plus y. So 2 times 300 plus y equals 970. So 2 times 300 is 600 plus y equals 970. Subtract 600 from both sides, and I get y equals 370. So your answer here would be there are 300 calories per cheeseburger and 370 calories per French fries. And there you go. A lot of times you guys they'll talk about investments of, one account at this rate, one account at this rate. Well, your accounts would be X plus Y equals the total amount of money. And then they might say like it's 5% interest for one account, 12% interest for the other account, for a total amount of money accrued in interest. You just want to make sure you guys are reading the equation, reading the word problem and figuring out what goes with what. It's going to take a second. It's going to take some practice, but we're going to do this a lot, and you guys will have word problems. So don't be surprised when you see them. I hope you guys have a great weekend, and I will see you on Monday. Valentine's Day is on Monday. Okay, bye.